Welcome, everyone, to a special episode of Tech Centric. This is something we hope to do more of in the future. We're calling it our Technology Deep Dives for our more technically skilled viewers. Since this is our opening episode, we figured, why not start with a fight? It is time for a data platform Smackdown. For our first competitor, we have Snowflake with Sachin Mittal. Sachin's a Snowflake superhero, and he's joining us from Gurgaon, India. For our second competitor, we have Databricks with Sippy Krishna, a Databricks data engineering professional hailing from the greater Cincinnati area. And finally, for our last competitor, the young upstart in the space, we have Microsoft Fabric with Josh Higginbotham, a Microsoft Data Platform MVP, hailing from the great state of Kentucky. So let's get started with this at a high level. Now that we know which platform each of you are here to rep, why are you passionate about that platform? Give me 3 simple reasons, and let's start with you, Sachin, for Snowflake.
Sure, thanks. Hey everyone, super excited to be here to represent Snowflake, the platform that is not just solving today's data platform but building for the future. So while other platforms are piecing components together, Snowflake delivers you one unified platform that is built for any data cloud, and it combines data warehousing, data lake, data sharing, and now AI ML workloads all into one secure environment. So whether you do have structured, semi-structured, or even unstructured data, Snowflake delivers the performance without headaches. But here, I'm not saying Snowflake has superpowers, but if it did, then these 3 would definitely make the Marvel cut. So I would start, let's start with the AI space. Okay, it's a single platform which is used to build data pipelines, LLM based applications via Cortex, and now you can run containers using Snowpark. So from SCD to type 2 transformations using dynamic tables to vector search and document AI, Snowflake Cortex agents are offering very powerful capabilities with zero model deployment. So in short, what I am saying is Snowflake is AI native, not AI bolted. Okay, like others platform, they are still figuring out where to mount the AI engine. But Snowflake does not need to go to the AI workshop. We are AI native born with Cortex in our DNA. Okay, so if I shift my gears, another standout capability is that Snowflake is cross-cloud, live collaboration without copying the data. So either you are AWS partner, GCP partner, or Azure partner, you can securely share and replicate the data in the near real time and without creating any egress cost nightmares. Okay, so unlike other platforms, those are having high egress charges. Snowflake replicates the data once per a region, and thus it saves millions of bucks for any organization. The third thing, of course, we know that with great data power comes great governance responsibility, and that's why my third superpower or Snowflake third superpower, that is enterprise grade governance, comes into the picture. So with object level access, row masking, row level security, tag based masking, automated lineage. So governance, not an afterthought process. It's a native process with the Snowflake. So, and hence this is the reason 8 out of 10 global banks trust Snowflake for PI compliance, GDPR, HIPAA, and SO2 without slowing the innovation. So that's what I am very much passionate about the Snowflake for this so much advanced capabilities into the one unified platform.
Okay, from now on, for the rest of the episode, everybody can refer to Sachin as Spider-Man. Awesome. All right. So, Sippy, let's move on to you. Databricks. 3 things, 3 simple reasons why you're passionate about Databricks.
Yeah, Sachin, that was a great speech. Hey everyone, I am repping Databricks today, the cool kid on the data block. So, what is Databricks? Think of it as your all in one data playground, whether you're wrangling with messy data, building dashboards, or training AI model. Databricks brings it all together into one powerful collaborative platform. No more tool sprawl, just data magic. And why do I love it? Let me give you like my top 3 things that I love about Databricks. One is that it's one platform to rule all the data engineering workloads, analytics workloads, AI, governance. As Sachin said, AI and governance is also not an afterthought for Databricks. It is like inbuilt. You have to start from governance, and AI is there in everything that you do in Databricks. Why juggle five tools when Databricks does it all in one, right? The second reason is that it's built for today and tomorrow. It's not just about reports and dashboards, right? You're ready for real time insights. It's the AI generation now and the machine learning advantage that you get with Databricks and whatever is next. Like, we don't know what's next. So, Databricks is ready for whatever is next. And third, it's the cloud chameleon. Azure, AWS, GCP, doesn't matter. Databricks plays nice with them all. Like, no handcuffs, no drama. And I'm not gonna keep on talking about Databricks. I'm gonna show you towards the end in the demo how it is.
All right. It sounds like you both think that your platform's the bomb. So I guess it's up to you, Josh. What about this
Yeah,
young upstart Fabric? What's it got to say?
it's going to be a tough battle, I can tell. Yeah, so I'm repping Microsoft Fabric, kind of the young upstart in the area, but don't let that fool you into thinking that it isn't capable of going toe to toe with Snowflake and Databricks. So for like my top three, the biggest thing for me is that it enables businesses to act on data like never before. We have the ability to roll out solutions both with what we call low code approaches, where you don't have to write any type of code to be able to deploy these solutions. And you'll see a little bit of that today when I kind of illustrate the power of Microsoft Fabric. And then we have pro code, so our engineers are still capable of building these advanced solutions in this unified data platform. Secondly, it is backed and at its core backed by AI. We have the Copilot functionality across every single workload within the Microsoft Fabric ecosystem, not only to make your teams more productive, to be able to develop solutions, but also to be able to put some of the work that would typically lean towards your engineering teams of support into the hands of the business, being able to provide capabilities for your business to use Copilot to say, give me a summary of what is on this page, this visual. What is this trying to tell me? Tell me what is going on with this code. Explain this KQL. Explain this PySpark logic to me so I can understand it better, increasing our ability to support whatever analytics needs that we have. And lastly, I just have to kind of go a little low on both of you, but nobody's doing reporting directly from Databricks or Snowflake. You got to go to Power BI to be able to do it, and Power BI lives on Microsoft Fabric. And so ultimately, we're going to be bringing your data from Snowflake and Databricks into Fabric and in the Power BI to be able to provide actionable insights to our business. So I got to go there.
Oof, oof.
Yeah.
Rough. So does that sort of, I think everybody said it's the one platform to rule them all. It's end to end. But what I think I just heard was, well, it's missing a piece, and eventually it comes to pray at the altar of Fabric. So does that make Fabric sort of the platform to beat here, or not necessarily? What do you think, Josh?
I think it's the age-old it depends. Nobody is sitting here advocating that if you're already a Snowflake shop or already a Databricks shop, that you should come off of those platforms and go all in on Fabric. There is definitely a capability where you can leave all of your data within Snowflake or Databricks, your data transformation, processing, all that within there, and then we can bring that data over in some form. There's mirroring capabilities from Snowflake and Databricks. There's shortcutting from storage accounts, both in Azure Blob Storage, S3, and Google Cloud Storage. So there's not this need to go in and rewrite all of your legacy systems into Fabric. They can live on top of this, and everybody can work together rather than just trying to rip everything apart and say it must all be Fabric. We can live kind of together.
Okay. So as the guy repping Fabric, what you're saying is, I'm happy sharing?
Exactly.
You don't want to win the fight? Is that what you're saying?
No, I just gotta, play nice with the others, and I like to think that I have a good friend that didn't coin the term, but it's healthy cooperation. So we cooperate together to drive in enhancements and evolutions in the data community. We all want to kind of beat each other because we're friendly about that, but obviously what's good for business is good for business, and we want to make sure that our data professionals are equipped to be able to leverage these tools properly for their needs.
All right. That's fair. That's fair. Little less, bloody than I was hoping for, but okay, y'all want to play nice, then we'll see how that goes. So what makes Fabric, given that it's the new guy on the block, right? Microsoft didn't just decide one day to launch Fabric because they went, well, there's nothing new under the sun, but I guess we want a product. They launched it because they thought they could differentiate. So, for Sachin and Sippy, how are you seeing Fabric come at your chosen platforms from a competitive perspective? What are they doing out in the market where you're going, okay, they're trying to differentiate themselves, they're trying to get a leg up on Databricks here and on Snowflake here, and how are your platforms responding to that? So let's start with Sippy.
So Databricks has recently launched a new capability in Databricks for dashboards that's called Lakeview, and maybe it's going one and on one with Power BI and Tableau. I'm not sure, but Lakeview is looking like that it's going to have some competition in terms of dashboarding capabilities for Databricks. Also, Databricks, I think, is more universal. Like it's been around for quite a while. It's like battle tested, if I may use that word. Like it's proven at an enterprise scale, and it's already empowering mission critical AI analytics workloads. And Unity Catalog is, I think, the kind of differentiator here for Databricks because it provides governance, which I think Fabric is getting there. It's with One Lake Security.
Okay. What about you, Sachin?
So if we talk about the dashboard, if you have heard, Snowflake has recently or just 2 years back, they have acquired the Streamlit. So that is totally Python based environment, and here you are full flexible, or it gives you the full flexibility to develop the dashboards. There is no limitation that okay, these functions are not supported or not. If you are Python pro, then definitely you can build a dashboard which is awesome. And yes, I totally agree on to it with comparison of the Fabric low code and no code solution. So Fabric is having an edge in terms of the Power BI, but Snowflake is giving you the flexibility more, which you cannot do it with out of box Fabric features, but with the Streamlit and with the Python, definitely you have an edge over it.
Okay. So it sounds like both are trying to lean into the visualization area to try to limit their dependability on Power BI. So, I mean, it sounds like where Fabric is the upstart in the end-to-end data platform space, it sounds like Snowflake and Databricks are kind of the upstart in the visualization space, trying to make inroads around Power BI. Is that fair to say?
Yes, you can. Yes, agree
All right.
on to this.
So, with that in mind, just real quick, just in case, again, a lot of our listeners are not as into the tech, they're more into the business side of tech, business enablement from tech. So can you just clarify for the listeners, Josh, what is the functional difference between Fabric and Power BI? Because they're not the same thing, but they are heavily related.
No, that's correct. So there is that kind of confusion of, all right, I used to log into app.powerbi.microsoft.com. I would get the Power BI portal. Now I'll log into app.fabric.microsoft.com, and now I get a very similar interface. And really, that's what it is. So Fabric was built as more of an umbrella of workloads or products underneath that, and Power BI was kind of brought underneath that umbrella. Power BI is still very much its own product, and it still gets the same type of release cycle and cadence that we see in Fabric. If you go out there onto the Fabric blog updates website, you'll see where there's weekly releases going out across all the different workloads. And so fundamentally, if you've been working with Power BI for the many years it's been around, the same interactions that you're going to work with in Fabric are going to be same. You have the workload context switchers, you have the very simple ways of deploying things. That's what's really nice about Fabric is, for the most part, it's as simple as saying new item and then giving it a name, and then it deploys out that workload, similar to how we would with Power BI. I go new report or new dashboard, and now I can start to do some development without having to worry about all the effort to spin up infrastructure or platforms to be able to do that. The way that you work with Power BI, though, is going to be very similar to interacting with any other platform. You're going to go through the get data connection string or get data connection pane, and you're going to connect to a lakehouse or a warehouse or a Fabric database. all within that same kind of interface that you would if you were connecting to Databricks or to Snowflake or Salesforce. So it's very much similar, and there's no real change to our Power BI engineer friends.
I want to start seeing this stuff. I think we're close to. We need some demos here, but there's one question I want to ask before we go to demos. We haven't had enough trash talk on this, and we need some trash talk. So I need to hear it. You know, if you're talking to somebody asking you, I got to choose between Snowflake, Databricks, and Fabric, and I got to pick one to be our data platform, and you're out there, and in the back of your head, you're going, my platform that I'm championing here today, that's the answer for them. What's the one thing you would lay down for each of the other platforms where you'd go, yeah, you don't want that platform because in this space, my platform kicks their butt. All right? So on this one, Josh, we're going to start with you. So what's the one thing you would say about Snowflake and about Databricks where you'd go, Fabric cleans their clock, you want Fabric?
That's a tough one. And that makes it sound like it's a bad thing for me. But the reality of it is that within Fabric, I can spin up a solution within an hour. We've seen in multiple instances where I've been able to go out and build an end-to-end data solution in things like real-time intelligence in the matter of an hour. This demo that I'm going to show you later, and I'm really proud of it, and I really think I'm going to beat Sachin and Sippy in the end. But
okay,
it took me 1 hour to build an end-to-end streaming data solution for payment data, which historically would take me days, weeks, even months, depending on all the hurdles and approvals that I'd have to go through and the skills needed to be able to kind of build that out. And I didn't write, for the most part, other than some KQL, I didn't write one line of code to be able to do that. You can't say that about Snowflake or Databricks. So I think that's my position on it.
All right, that's tough. Jeez. Okay, Sachin, you're up, man.
Let's be honest, very first thing over here, some platforms move to the cloud like we move furniture with lot of adjustment, heavy lifting, squeezing things through the door. And at the end of the day, they realize that their couch doesn't fit over there. But Snowflake is far different from this. Snowflake was not retrofitted for the cloud. It was born into it. Okay. So no legacy baggage, no staircases, no repackaging. Okay. Still some of the customers or some of the platforms are still in the experimental phase, but Snowflake's, their customers or our customers are already experimenting and already using it into the mission critical finance, healthcare, retail pipelines on Snowflake at a very petabyte scale. Okay, one more thing with the Snowflake is that most of other tools, I'm not naming those tools, but yes, they give you, these platforms are the data tools, but Snowflake gives you a launch pad. How? With Snowpark, Cortex AI, Streamlit, native apps, ML, you name it, everything are already inside the Snowflake, and it helps you to monetize your AI driven application inside the Snowflake. So definitely, I would say Snowflake is a unified platform which is adopted by huge number of the customers. And to on a lighter note, as Josh was saying that he took 1 hour to develop his job, I'll show you the demo. I took only the 10 minutes into the Snowflake to develop the complete flow using the dynamic tables. So Josh, please wait and watch for this.
Oh. All right. Sippy, you're up.
One thing that stands out with Databricks that I think also stands out above Snowflake, not just Fabric, is that its data lineage capability, which is completely out of the box. I have built some pipelines using DLT, and whether you build pipelines with DLT or no DLT, it provides you data lineage capabilities, which is something that I have seen in Purview, but that is like a separate product as Fabric maybe, as in it's not inbuilt. You have to do some work in it. Like Josh said, like he built the solution in an hour. Whatever solution you build in Databricks, whatever time it takes you, data lineage is out of the box. You don't have to do anything for that, and not lineage only at the table level, but also at the column level lineage. And I'm going to show that. The second advantage of Databricks where it stands out, at least over Fabric, is the uniform protocol with the Delta protocol. Like Databricks are the creators of Spark technology. They're the creators of Delta technology. They're the creators of Lakehouse technology. So before things go out in open source, Databricks are the creators of those things in Delta. Like if you have to use monotonically increasing IDs, sequences, like that's not yet available in Fabric. If you have to use open source Python libraries, they are not yet available in Fabric. Like PyPy is not available in Fabric. Databricks integrates with a lot of other open source technologies like Daft, DBT, and a lot others. It integrates well with partner companies, which I think Fabric and Snowflake are still getting there. So initially setting up Databricks, I agree with Josh. It might take some time, but the reason for that is because it provides that strong cluster support. Other thing I like to this is where it beats Fabric is like with Fabric, you have to pre-plan your capacity. With Databricks, you don't have to do that pre-planning. You pay for whatever you are consuming. It's not that your capacity is going for waste because you're not consuming it. I mean, that capability is not there, and there is no throttling with if you go beyond that capacity. You know, you can increase the auto scale your clusters. There's no throttling in Databricks with that. So I think these are the main factors which still I believe Fabric is getting there.
Lord, that was brutal, Josh. I don't know, man. I don't know. Well, I think it might be time for you guys to put up or shut up. I think it's demo time because I heard a lot of trash talk, which is what we needed. But it's time to put your money where your mouth is. So I think we're starting with Sachin. You are up, sir, with your demo.
Sure. Let me share my screen. So I'll just brief in a very short time that today we are going to showcase how Snowflake simplifies the data pipeline orchestration using the dynamic table and the alerts, which are fully continuous. Okay, so the problem statement is that let's say you are a data engineer at a retail company and you are collecting sales, product, and the customer data, which is very critical to the business, and your goal is you have to track the daily and monthly sales performance, you have to track the customer behavior and purchase trends. Also, you need to identify that if there is any inventory management that is going to the below stock level or below inventory level, and if there is such case, if there is any low stock identification, you have to send an email to the stakeholder. So if I go with the traditional pipeline, some of the challenges we could see over here that we have to rely onto the external schedulers like Airflow or cron jobs along with the custom scripts to manage the data fresh and the orchestration process. Also identify the scenarios like low inventory levels in the near real time, which becomes very cumbersome and the difficult, okay, nowadays. So also one more thing in traditional pipeline is that it is very difficult to manage the dependencies and validate whether your source data has been refreshed or not, and so that all the other dependent tables gets refreshed accordingly. But once we move to the dynamic table, so dynamic tables are smart tables that keep themselves up to date. Okay, so if you see on the left side, these are my source tables which has been populated by streaming or any ETL process. But on top of it, if you see, these are the three dynamic tables. So once we have the dynamic table on top of our raw table, these are automatically refreshing the data inside the Snowflake. So we do not need to worry, or we do not need to concern that, okay, or we do not need to deploy any external scheduler to refresh this data. Okay, so now we would see how we can implement it into the Snowflake. So this is my Snowflake screen. Okay, so say I do have one database, and see, these are the three tables. If we talk about customer info, which is having some data regarding the customer information. Another table is product stock inventory, where we are maintaining the product stock level. And the third table is the sales data, which has been purchased online by the various customers. So these are the three source tables we have been populated or are getting populated by the streaming process. So on top of it, see, this is a simple command. Okay, if you see this table, if you see, the data is already in the form of the JSON format. Okay, so what we are doing, we are just joining customer table and sales data table, these raw table, and creating one dynamic table. Okay, so let's say I've just created this dynamic table. Okay, and you see, once the dynamic table gets created, the data gets automatically populated in this dynamic table. So it has done the join between your raw tables, customer and sales data, and the data gets immediately populated in your dynamic table. Now, next step, we are combining this dynamic table with another product inventory table, the product stock inventory table. So, okay, so let's say this is again, we are creating one more dynamic table, which is again based on the previous dynamic table. Okay, so if you see and verify the data into this dynamic table, the data gets reflected and 1,000 records are already available. Okay, so if you see, assume that within the next 10 minutes you are getting streaming data into your source table, that is sales data. So let's say I'm just inserting 10,000 record into my source table. Okay, so we will see how quickly this dynamic table gets populated automatically. Meanwhile, if you want to see the lineage or the graph inside the Snowflake, you can easily visualize over here. If you go into the Snowflake databases, inside this you see dynamic tables are there. So we have created two dynamic tables over here, and if you go here, only just you click over to the graph and you will see that. Okay, so this is the dynamic table. If you see, these are my source tables. On top of it, this was my dynamic table got created, and this dynamic table was created on top of this. So this is the complete flow we have over here. Okay, so now if you back to our demo, we have just inserted 10,000 more records. So we'll see whether, see, our dynamic table gets refreshed automatically. There was no manual intervention is required. So within a maximum lag of 1 minute, my table got refreshed automatically. So now we are extending this demo to one more level, that nowadays Python is very much popular and they are migrating their Python pipelines into the Snowflake. So yes, we can use the Snowpark code to develop the Python logic inside the Snowflake. Again, a unified platform. You do not need to go outside anywhere. So let's say I've just created one function, Python function inside the Snowflake, and we are leveraging that Python function to calculate the cumulative amount, to calculate the cumulative purchase of the customer. So again, one more dynamic table we are creating. So if you see, one more dynamic table I have created, and if you go over here and see your graph, see over here and you see the graph, see, yeah. So now two raw tables, two dynamic tables, and top of this dynamic table we have created just one more dynamic table over here. In extension to it, to make a complete workflow, okay, so we are creating one more dynamic table which is responsible to check whether the inventory level, whether our inventory level is less than 10% or not. Okay, so let's say I just created this dynamic table, and here we would be checking that if there is any inventory level less than 10, then we will be shooting an email to the respective stakeholder. So if we see, if we run this query and see, in this dynamic table we are having these inventories, 32 inventories which are having stock level less than 10. So what we will do on a simple, this is the one command, this is alerts which are in the public preview now. So you will just create an alert and activate these alerts, and within a 20 or 30 seconds you will see an email to your email box. Yeah, see, this is the email now. You will get the email something like this: what, inventory running low for certain products, please check the inventory report into the Snowflake table. So you my point is that no Airflow, no cron job, no Matillion, no other tool, everything is dealt inside the Snowflake, and this is the final graph. If you see everything, so this is, if you notice that this is the complete a lineage graph or a lineage graph for the dynamic table is already readily available inside the Snowflake, and that will give you the complete picture that how the data is flowing in your system or in your pipeline. So that's what I was talking about, Josh, that the same pipeline, it took me around 10 to 15 minutes to develop the entire logic with this sort of the pipeline.
Excellent. All right. Well, gauntlet thrown down. Sippy, what are you going to do about it?
All right, let me share my screen. Ready. So I'm gonna start the data refresh here first, and then I'm gonna talk about this. So this is a streaming pipeline combined with batching data. So it's both batch and stream combined. And I have not created any of the visuals that you're looking over here. This is all out of the box created by Databricks. The inputs I provided to this is, let me show you. First of all, this is already integrated with our DevOps repo. So that was a very easy process to do that in Databricks to start with. Then we have got the notebook over here. And here we can also do our documentation. Like you can say I've done the documentation within the notebook itself. So you don't have to maintain separate documentation. Like we all are programmers and developers and we all forget what we have done. We have got the Databricks assistant built in, and I was just asked probing it for this demo that can you explain me what the notebook is doing? It's a LLM based model. You can do that. And here I'm using Delta Live tables for doing streaming as well as for the batch tables. And the capability that Delta Live tables provide us is out of the box data quality. I have orders table and a customer table. Customer is placing some orders and we are doing a Medallion architecture approach over here. And we are doing a data quality rules, simple ones for now. Valid order status, valid order price, and valid market segment for the customers. Then we are getting orders data from a Databricks sample data set for orders, which is a DLT table. And the source is a sample table that Databricks provides out of the box. In another example, we are using Databricks volumes, and really Databricks volume is just like a storage behind the scenes. I'm using customer file. It's a JSON file as a source, and I have already provided this file number 6. So all these files, when I running it, rerunning it, it will not be reloaded in this case. It kind of maintains that checkpoints, like what you have already loaded. It handles the schema evolution, like if your file is changed at the source, I have provided that what schema evolution mode you want to use. In this case, I'm doing none, but you can change it to different schema evolution modes. I'm doing an append flow, 2 streaming flows, one from the autoloader, which is our cloud storage, and one from the table gets combined together. And I am not going to walk you through this code because I know this is a lot. So what instead I'm going to do is, let's walk through what DLT created for us from the code input that I provided. And this is out of the box. Like I did not do any of this orchestration. You can choose to do orchestration in Databricks if you want to. You can write your code in plain Python, and that's also powerful and supported with Databricks. My last project was exactly on that. You can do orchestration with that drag and drop GUI, or you can write a code to create these workflows, or you can use DLTs where you don't have to really do any orchestration at all. It's showing me over here how many records were loaded. There is a data quality screen over here where you can see how many rows were dropped, or if you want to fail your process, if the records have incorrect data, you can do that with the DLT pipelines. And here I am loading 7.5 million records. You can see in 39 seconds. I'm using the smallest cluster here for this demo, guys. So that's how long it took to load that amount of data. It joined that data in 45 seconds. 7.5 million rows with the smallest cluster that I have over here. And then this is my batch data. It's showing as a materialized view, and I'm joining these two as a view. This does not get materialized. This is like a temp table in SQL. And then here I'm combining it into a silver table. Further, what I wanted to do is I wanted to show like how do I divide this silver data or the silver data into different sets of gold tables. And I'm using parameters in DLT here that if my order status is O, move it to this table. if my order status is F, move it to this table. And that's a setting that is available. And I'm also using this as a parameter in my code that, hey, do this if the value is this, and so on. So this is like overall, it provides an orchestration piece, it provides you data quality, it provides you number of rows dropped and uh, which are cleaned up, and also it's doing the audit logging. Now you would have seen in the code, I have not done anything to log any errors or the information. Everything is being logged over here by default. Like I'll show you a pipeline which I ran before that failed, and I can see what error it had, and I can click on that and see what the error was. So you get out of the box capabilities, like I did not code any of that. So the next thing that you can do with your data is you can connect to Power BI, go to Marketplace, select the Power BI data desktop integration. When you click on connect, you'll get the connection file, and then you can visualize the data in Power BI. Lineage, a very important piece that's um, I'm going to show you here is that if you click on the lineage, you can see the entire lineage graph. And let's expand this further. And not just that, we can see lineage at the column level. Customer key is getting generated from these two tables, customer key, and if I click on that, I can see where this is coming from. I really find this cool, like how neatly it is showing us the lineage. That's all. I mean, there is a lot more, but there's so much we can cover in the time that we have.
Well, Josh, you got a lot to measure up to here. I hope you're ready.
Yeah, those are good. It's going to be tough. All right, I'm going to give it a try, though. So let me go ahead and share my screen.
I will say I saw the very knowing nod when you said Power BI there, Sippy. You immediately got the
Yeah, that's right. Yeah, you always got to go back to that Power BI. So, all right. So to start off with my demo, we're going to go into my workspace, a little throwback to one of the greatest movies of all time. There can be only one. And at the end of this demo, I think everybody's going to understand who that's going to be. But so I'm in my workspace within Microsoft Fabric. I want to first highlight this top section right here. We've got what we call a task flow, which is a really cool way of just visualizing what is going on within this workspace. So I can provide this nice diagram to let people know as they enter in like what is happening. So I've got data coming in both from stream and batch, similar to like what Sippy and Sachin were doing in Snowflake and Databricks. But I'm moving my streaming data into a KQL database within an event house. I'm moving my batch data into the lake house. But what's really, really cool about Fabric is the concept of shortcutting, where I can keep data where it currently resides, but then just give a pointer to the data in its other location. So I've got a shortcut of my data in the lake house presented to my event house and vice versa. So my streaming data can be enriched from my batch data, and my streaming data could then now be used within my lakehouse for things like analytics and long-term lineage and things like that without having to go through the effort of doing all this ETL work. My payment data is now going into a payment dashboard enriched with my batch data, things like customer address and the invoices. And then what's in the lakehouse can ultimately go into a Power BI report and dashboard for analytics based off of whatever business needs you have. And lastly, like what we saw with Sachin, I've got the ability to notify the business when certain events happen. In this case, I want to let the business know when payments come in because we like money and we want to know when that money is coming in. But let's start off by how did I do this? So, I wanted to be able to leverage streaming technology. So I went over to talk to my friends over on the application dev side. I said, hey, I've got this concept called an event stream where I can give your application connection string details to this event stream so you can push data in. So I've got this payment source. So I'm giving these credentials over to my application engineer so they can plug it into the application. So as payments come into the transactional system, it's going to go ahead and write it into this stream. That way I can leverage it here and now rather than having to go through that batching based process. Like I don't want to wait every 15 minutes, every hour, every day. I want that now because I want to understand when this payment is coming in. So as it streams in, then I can go do things with this. And like one of the things that I saw with Sachin and Sippy's demos was it was a lot of code to be able to handle all that. Whereas with this, if I wanted to transform this data, I could just drop it down, go in and edit, connect things up. I don't have to rely on code to be able to do that, which is just really, really cool. But I'm going to write this into my event house, my KQL database. That way I can go in and report off that within our real-time dashboard. But then I'm also going to go ahead and immediately notify. We just talked about being able to write this into our event house, but now I want to be able to notify as payments come in because we love our money and we want to be able to be notified when that money comes in. So I can go ahead and add a data activator as a destination to then use this data and say, based off these conditions, I want to go alert. It could be, I've got a high dollar amount payment that's come in and I need to go through some level of review and audit for that. I can do that through that activator. And by putting it into the stream, I get it right here and now as the data comes in. But there's other ways that we can do this where we put it a little bit further downstream after we've done some level of QA and cleansing and checks on it ourselves. So now that data's kind of come in, now let's go look at what actually got processed. So I've got in our event house, I've got my KQL database called customer_EH. I've got our bronze payment table, which is where this data is coming in. So I've got customer ID, invoice, payment amount, payment date, and some like audit fields that the stream goes ahead and puts it on there so I know when the record came in. And then I leverage something called an update policy to be able to go in and automatically handle the processing of this data. So as the data comes in, I've got an update policy that goes in and does something with it, some level of transformation. And think of it like a trigger on a table. In, like, say, SQL Server, we had this concept of a trigger. We have a concept that is a trigger. Well, as a record gets written to this bronze payments table, I can then go and do some level of transformation and write it into another table. So in this case, I'm going in, doing some data type changes, scrubbing some data, and writing it into our silver payments table. And all that's written in KQL. Now, if you don't know KQL, it's not that big of a deal. There's different ways that we can learn this. There's tons of tutorials and lessons around that. But also, if we go into our KQL query set, which is where we're going to write, it's kind of like the script editor within this database, I can use our friend Copilot to go in and write KQL for me, or explain KQL logic to me, or tell me what is happening within this data. So there's ways to do this without having to worry about picking up a whole new language. But we're not going to talk too deep into that. Hopefully we'll be able to do another video on that in the future. But as I've got this data now into our payments table, I want to go in and do some level of visualization. And again, like, we didn't see that with Snowflake and Databricks, so it's kind of my like swan song, how I'm going to win this in the end. So I'm going to open up our dashboard, and we see as our data is coming in real time, this dashboard is updating. So I'm seeing things like our total invoices. I have 100 invoices out there. I've received 96 payments. Our total invoice amount is in the 50,000 range. Total payments is 33, so we have an outstanding balance of 18,000. I see that I've got unpaid invoices of 33. And then I've got some details underneath here. So not only can I give these like card visuals to show you right in your eyes like what is going on, I can use conditional formatting, but I can give some detail behind it. So I can go and look, and I've got some color coding or conditional formatting set that shows me some details behind the invoice. In this case, I'm triggering off of the age of the invoice. So things that are older than 90 days, I'm marking red as something I need to go in and hunt down what's going on. I need to go figure out why this customer hasn't paid their invoice within this. And then lastly, like I showed you before, we have that payment activator. So all I've got here, and obviously in production, we wouldn't want to do this. We wouldn't be alerted on every single payment, but I can set up an alert that tells me on every value, and there's all these different conditions that we can set, but I want to trigger an email, and with the data that's within the stream, I can use that as what we call references or properties within this. So I can add that data within the subject or the headline or the message. So now I can not only send an email, but I can provide the actual details. So I'm seeing that I have an email in my inbox saying that this invoice was paid with this amount. So I don't have to worry about alerting a team and then them having to dive into the analytics tool to then figure out what's going on, we can present all the data that they need to then be able to go and triage the issue within whatever system this came from. And this can be leveraged even outside of real-time intelligence within Fabric. You can use it within any other workload within the Fabric ecosystem. And I will say, Sippy is right that Fabric does not have as granular of a lineage view, but it does have a lineage view. So I can go into the workspace and I can get a lineage of the workspace. And then in our OneLake data catalog or OneLake catalog, I can go to the item itself and also see lineage and see those items. But you cannot go to the table column level like you can within Unity catalog. So you do kind of win there. I'll give you that.
Wow, you were finishing strong and then you gave up a point. I don't know, man. Well, those are some pretty cool demos, and I think the message for our viewers at home is going to be pretty clear. We're not naming a winner here today. You are. So the idea here is go in the comments, cast your vote. We're even going to look into putting a poll out there so people can vote for which one you think won the Smackdown versus which one you think is the better platform overall. We'll take that information and we'll use that in a future episode, I am sure, to crown a winner. But either way, this has been our first inaugural episode of Tech Centric Deep Dives. Thank you so much for joining us. We look forward to seeing you in the next one. Thanks, everybody. If you want to keep the conversation going or suggest an idea for a future episode, please comment below. And as always, if you have a question for me or one of our guests, you can contact us directly via the contact information in the description below. Thanks again for joining us, and we'll see you in the next one.